Hello, so in this video I'm going to be introducing logarithms suitable for AS level and full A level mathematics. We'll be introducing them, we'll be creating some logarithm laws, and I'll do some examples using the logarithm laws, and then hopefully we'll solve log equations in the next video. Okay, so to start off with, a logarithm is I introduced from the idea that if I have something like 2 to the power of x equals 4, for example, and I wanted to find the x, well I could say x is equal to log base 2 of 4, which on your calculator, if you do that, you get the answer of 2. Okay, because you know that 2 squared is 4. This is where the idea is coming from. 10 squared is 100. Yeah? So 10 to the x is equal to 1000. You should know what that is. This x should be 3. But if you wanted to make sure, you could use logarithms. So log base 10 of 1000. You want to do that on your calculator. You have log base 10 of 1000, and I get 3. So the answer to this would be 3, because you know 10 cubed would be 1000. So this is where the idea of logarithms comes from. We're using the idea of indices to be able to find the power, which is what logarithms are. They enable you to find the power of something. It's used a lot in exponential decay, as you will see in the coming videos when I introduce you to the natural logarithm. Not in this video, it'll be in the coming videos. So we'll introduce them there onwards. So hopefully we can move on nicely from there. So the next kind of stage is the logarithm laws, or the laws of logarithms. Now, these are the ones unfortunately you have to learn, but you should be well versed in them, because you know your index laws. Now I did index laws in the previous video on this channel, so if you want to have a look at that, feel free. But now the logarithm laws. Now, if I start off, I'm going to draw this table because I want to show you how similar the logarithm laws are to the index laws. So, for example, if I had a to the m times a to the n, that's a to the m plus n. Now, logarithms are the inverse of indices. So, if we multiply, we add. If we add, we multiply, which is what this is. Log base a of b, or x also, plus log base a of y is log base a of xy. So it's the inverse of the indices laws. And these are now your log laws. But you have to write the base every time. You'll see when we get to the natural logarithm in the coming videos, you'll see that we don't have to write the base all the time. Because we know the natural logarithm uses base e, which doesn't hardly change. We don't have to use a base when we get to the natural log, which we'll see. But let's crack on with these. So we've got one for adding logs. Now, there's the same process with subtracting logarithms. So if I had a to the m divided by a to the n, that's a to the m minus n. Now, if I'm subtracting, I'm dividing, right? So that's what we have to do in the logarithm laws. If I have log base a of x minus log base a of y, I end up with log base a of x over y. And that's where that one comes from. So these are very, very similar, but they are also used in various methods, as you'll see in a minute. Now, the next one is a little bit more complicated, but if I have a to the m to the n, that is a to the mn. I've introduced these in the previous video, so if you don't know these, which is quite surprising if you don't, you need to go back and watch that video before you crack on with it. Okay, so the log law for this is if I have log base a of x y to the power of y, this is actually written as y log base a of x. So you can bring the power down to the front. Now usually if you see something like 4 log 1 1, I can say log base 1 of 1 to the 4, which is log base 1 of 1. Okay, so that's where this is coming from. Alright, so just if you're wondering. Now, so we have powers of powers, division, multiplication. So the next stage, this is if and only if, by the way, so these can be interchanged. You can start that way, go to that way, start this way, go to this way, and so on. The next one is you can't have negatives in logarithm laws because the log curves, yeah, will never go below. They always have a limit as h gets closer and closer to 0. We can get closer and closer to 0, but it will never touch and will never go into a negative. As you'll see with the natural logarithm graph, you will see it will get closer and closer to 0, but log of 0 is actually undefined. We can't actually state what log of 0 is. But you can get pretty close, and you can try it on your calculator. You can get 0.00001, and you get pretty damn close to 0, but it's not quite there. It is quite close. Anyway, back to these. Sorry, I'm going off topic, but this is how I introduce logarithms to you quite a lot of the time now. So, the next one is if we have a to the 0 equals 1, yeah, then log base a of 1 is 0. Try it on your calculator, and it has to be true for whatever number. So if I try log base 6 of 1, I get 0. Yeah? You can do this for any value that is belonging to the real numbers, where x belongs to the real values. Yeah. So that's that one. That's 0 indices. We have also a to the 1 is a. So that means if I have log base a of a, I get 1. So if we stick with the 6, just pick up the calculator. We go 4 of 4 actually. Let's do that one. We get 1. Okay. So this is the proof of your logarithm laws and where all these actually are coming from. Now, a lot of them you will recognise from GCSE. You'll recognise the index laws from GCSE, but the log laws are the reverse of your indices laws. So if you know those really well, you don't really have to learn these, apart from maybe the third one, which you'll use a lot, especially when you're solving log equations, which we'll get to in the next video. But the next stage I want to show you is now combining these logarithm laws to doing examples with them to write logarithms as a single logarithm. You might have log base 3 of 3 and like log base 3 of 3 minus 5, for example, I've seen in the past. So you might have log base 3 of 3 minus 5, and you'd have to deal with putting that as a single logarithm. So I'm going to go through 5 examples in the next part of this video to hopefully get your mind at ease, so you don't have to learn them all, but it is recommended. So that's the next part. So in the next part of this video now, I am going to be answering these 5 questions using the log laws I've just found, writing each one as a single logarithm. So for number 1, this is a nice easy starter to get us going here. I need to, if I'm adding logs, I have to multiply these here. So I've got log, the base stays the same, of 21 times 4. Well, 21 times 4 will give you 84. That's number 1. Number 2, log base 4 of 18 minus log base 4 of 2. Well, using the second law over here, I can, if I am subtracting logs, I can divide. So I've got log base 4 of 18 over 2, which is then equal to log base 4 of 9. Okay. For number 3, I'll do number 3 down here, just so I've got a bit more room. So, using a third log law, I can bring the power up using the power rule. So I've got log base 3 of 4 to the 5. Now, I'm going to sort out the bracket. So I've got log base 3 of 3 plus log base 3 of 4. Now, I'm adding them so I can multiply the 3 and the 4. So I get log base 3 of 12. So now I'm adding, so I can complete this now by saying log base 3 of 4 to the 5 multiplied by 12. And that will give you log, I'm trying to do that in my head, that is 4 to the 5 times. Have a look on the good old Capsule. And that is 12288. So 12288. That's how we do that one. Number 3. So that is equal to log base 3 of 12288 for number 3. For number 4, I've got 5 minus log base 6 of 4. Now, this is sneaky because if you know what log base A of A is 1, using this log law here, that's what I'm going to be using for number 4. If you know that's 1, but I want 5. So 5 must be 5 log A of A. So that must be 5. Now, because I'm using base 6, I don't want to be changing the bases around, so I want to be using the same base. So I want to be using 5 log 6 of 6 minus log base 6 of 4. Now, because I've got this, I can use the third log law to bring the power up. So I've got log base 6 of 6 to the 5 minus log base 6 of 4. So solving that, I can do 6 to the power of 5 on the calculator, divided by 4, which will give me 1944. So I get log base 6 of 1944. Okay. So all that is just doing that on the calculator. Okay. For the last one then, it's a little bit more complicated, but it doesn't make much of a difference. Now, using bid maths, I'd like to do this bit first. Alright, now I'm going to show you a way that a kid that maybe is at a CD level would go about this. So, if this is the CD version, so people at a grade C, grade D, people will do this. So I've got log base 4 multiply, so I get 7 minus log, okay, I can bring that up, so I get 4 of 4, and I get log base 4 of 7 quarters. Okay? Yeah. Now, that's correct, that is the right answer to this problem, but is that a way a grade A star student would tackle this question? No. That is, no, don't do that please. Now, I want to be looking at log law number 4. Log base A of 1 is 0. So that means if I had log base 4 of 1, well this is the same as 0. This doesn't change. So all I'm actually doing is ignoring that, so put a line through that, and I'm actually just doing log base 4 of 7, take log base 4, so I've got log base 4 of 7, take, so the person at grade C did do this correctly, and you get log base 4 of 2 squared. Let's sort that out. So we've got log base 4 of 7 minus log base 4 of 4. Well, log base 4 of 4 is 1, so that's just this, take 1. In effect, this is log base 4 of 7 over 4. So we did get to the correct answer with the CD version, but as we know this is 0, so you should state that anything with a base of 4, not anything with a base of 4, but any base to 1 is 0. You shouldn't be knowing these from our indices log laws that we've seen in the previous part of this video. So that is 5 examples. They do get harder in difficulty, so number 5 is something I would expect at A to A star level. Should be able to do those. But using these now, our next stage is to be looking at maybe log equations, and solving log equations or exponential equations, and we'll be looking at the natural logarithm in the next video. So that is how we can use log laws to simplify some logarithms, some logarithm expressions. Thanks for watching this video. If you want to even more, make sure you like and subscribe, so I know I need to make more of these on the other variations of logarithms that you see at A level. Don't forget this is suitable for AS level as well, so if you're doing year 12 content. And also this is good for any revision for any exams that come up. So thank you very much for watching this video today, and hopefully I shall see you in the next one. Peace out, Math Boy is out.